understand a little bit more about H2O AutoML. H2O is an open source machine learning framework with full tested implementations of several widely accepted ML algorithms. You just have to pick the algorithms from its huge repository and apply it to your data set. So I will give an illustration of that if I have to use AutoML GUI, how I'm going to pick the data and how it's going to go ahead and pitch the results across different models by creating the leaderboard. Also note that it contains the most widely used statistical and ML algorithms. H2 provides an easy to use open source platform for applying different ML algorithms on a given dataset. It provides several statistical and ML algorithms including deep learning. Now, how does the machine learning work typically? So we know that we're going to have a data set, we're going to train the data, we're going to train our ML algorithms basically, right? And we're going to have a model input, and then it will go through the ML algorithms, and then we might have new or more data which we can put that back into our algorithm. Then we're going to make the predictions. Finally, we will have accuracy. We're going to say is it acceptable, we're going to give a pass successful. Otherwise, if it's unacceptable, we're going to go ahead and retrain our model, tweak the data set, massage the data set probably, and yeah, and then basically follow the cyclical process till the point we have the acceptable accuracy of the model. Now let's talk about the H2O types of machine learning. It basically supports supervised machine learning, unsupervised, semi-supervised learning, and reinforcement learning. Now let's look at the architecture of the H2O stack. So if you see the top part over here, and let's say we were supposed to be running some algorithm, you can pretty much run the algorithms in R, Python, Flow, right? So H2O stack diagram is split into top and bottom section with network cloud dividing the section. So over here we have the network cloud. Top section shows the REST API clients that exist for H2O. So if I have an API client, I can fetch the results and render the results to the dashboard. The bottom section shows the different components that run with H2O JVM process. Those are Java Virtual Machine process. These are Spaark, Kubernetes, Hadoop, and so this is basically our components that sits into the H2O JVM. All right, so and these blocks basically are basically over here we have H2O prediction engine, then we have the bunch of machine learning processes which are GLM, GBM, all our models, deep learning, k-means, PCS, and then we have a parser sitting on the left. And then we have, in order for our jobs to run, we have some jobs and schedulers and folks and join. And finally, we have some more blocks over here for the distribution of our data and some hash maps also sitting on our data set. Finally, to run those on a cloud infrastructure, you would need, or for streaming the services, you would need Kubernetes, you have Spark, and standalone H2O framework services, which sit as H2O JVM process. Then, rather than just simply boring you, I'm just going to go ahead and import the H2O AutoML from the H2O.AutoML. Also import the H2O package. Create the instantiation of the H2O and specifying the maximum memory size to 16 GB, which would render following result sets. So we would have information about the cluster uptime, time zones, free memory, cluster status, which means healthy, number of cores allocated, and blah blah blah, including the Python version. Now, also understand that H2O ML capabilities. It basically supports automated, supervised, and unsupervised ML algorithms, automatic data processing, cross-validation, grid search, random search, variable importance, model performance metrics, and plots. And let's take a quick example of that. So if I come over here, here are the major components of H2ML, which is AutoML training. That means users are allowed to train any models using H2O AutoML using their own train test dataset. Then it will display the leaderboard, which would have a view of AutoML leaderboard to rank the model. So you would have a view of all the models, how the data was trained, and which model supersedes the rank of accuracy as well as the root mean square error. Then we have AutoML Viz, which basically shows the feature importance, shapely the contributions, And then in order to explain the features, we need model explain, which also explain any model using feature importance. Finally, for deployment, you can download any model into Mojo model format, and we have a link over here which points back to docs.h2o.ai. And then if you go to automl.html, you can see the further documentation on the deployment. Now, if you observe the screen, as a user, you can go to AutoML UI, train a dataset after importing a dataset. Let's say you have that dataset. You can go ahead and train that dataset. You can specify the algorithms you need. Over here, we have selection for GLM, GBM, XGBoost, deep learning, stacked ensemble, right? And once you have that, you can run the AutoML, right? Then you would have the results as like a leaderboard, where leaderboard would dictate which is the leader model over here. So we have AutoML XRT as a leader model with accuracy of 99%. Then we have stacked ensemble, which have a little bit lower accuracy of 95%, followed by GBM and other XGBoost models. And also you have log loss and then RMSE as in mean squared errors. So that's a very good view of how to visualize, your models, and the pipelines of the models which have run with a higher accuracy stays on the top and the other ones goes in the bottom. Then also make a note that you can also see through AutoML Viz what is the accuracy ROC score for all the models. So we can definitely observe that some of the models were high performer where we have accuracy between 90 to 95%, and some models exceeded the 95 percentile, and which basically using this color code you can detect which model was a leader for the highest ROC score under the curve. Likewise, you can also see the model correlation in heat map, which I'm sure you are accustomed to that. But the idea was to be able to take the dataset, import the dataset, do the screening of our dataset, and then apply the training using the AutoML set of models. And you can choose the models you want to train on. And then a leaderboard would dictate what is the automated pipeline looks like, with the leaderboard dictating which is the leading model with the highest accuracy. And finally, you can also visualize the importance of the features and the ROC scores. And also you can do the model explain, which would have basically all the features and uh, their importance by the model. So that's basically in nutshell how H2O AutoML works. Time to go ahead and complete that exercise. In the next lecture, I'll pick the data set um, and then be able to import that data set and start training and utilizing the H2O AutoML factory packages to make the predictions. So stay tuned for the next lecture. Thanks for joining.